We have definitely saved the mind bender for the last discussion, and I can tell you from some pre-game discussion, the dimensions of this one are just tremendous. So this could go anywhere. Where we are in 49 minutes from now, it could surprise us all. But we've got Dr. Josh Rhodes. He's a research scientist here at UT Austin. He's applying all those analytical skills in very much energy systems, electrical systems, resource systems. So he's thinking hard about the AI applicability and analytical applicability, all the things we're discovering. He's thinking hard about how that gets applied to all these problems and opportunities you've been hearing about today. And we've got Dr. Robin Tuluie. He's the founder of PhysicsX, which is a AI firm. You can call them and say, hey, I have this problem, and they will try to solve it. He's the chief science and engineering officer there. And so you will hear from him all the cutting edge ways in which some of these great technologies we're potentially applying them. So gentlemen, welcome. Thank you so much for doing this. We were going to just have this be moderated by AI, but we couldn't trust what the AI. We're just going to feed in this morning's, transcripts and see what it asked you. That would have been a good experiment.
We'll use actual intelligence instead today?
I guess. We'll see. Well, let me jump in, and maybe the place to start is with you, Dr. Rhodes. Give us kind of level set us around when we say AI, what are we really talking about in today's world? Like, just kind of get us going in terms of analytics and capabilities and the buzzwords we need to understand before we start jumping into some of the really complicated stuff that both of you are doing.
Yeah, absolutely. So, a lot of folks have, we've had the techniques that we're using to generate these models that can, answer our questions and, allow my students to cheat on their homework and all that kind of thing.
We got to do the first things first.
Right, yeah. The branch of, analytics that we're talking about, machine learning, these, neural networks that underlie the development of the models that can talk back and forth with us. We've had these for a while, but we just haven't really been able to, push them kind of as far and as hard and have them ingest so much data that they're able to essentially, act like us, or to be able to at least, respond to us in a way that we, talk and respond to each other, and, feels like that they're, also kind of thinking there in the background, which we, then we talk about them as, artificial intelligence. A lot of the stuff I do here at the university is focused around energy, and so a lot of, I kind of, when I'm thinking about AI, I'm kind of thinking about it in terms of, three ways. There's, energy for AI, and then there's, AI for energy, and then, because we are at a university and I'm teaching classes this fall is, AI in education. There's like kind of the three ways that I'm kind of, thinking about it. And, the thing with energy and AI, we're hearing a lot about the energy use for AI, and I think a lot of the hype is real, but a lot of it is hype. There's a lot, the numbers out there are large. We heard last panel talking about ERCOT demand doubling in the next 5 years. Now, I kind of take some of those numbers with a bit of a grain of salt. I think that would be physically really, hard to do. But I mean, one of the reasons that we're seeing numbers like that is, time to market is everything when it comes to, is everything right now when it comes to AI. And, and a lot of, I think what we're seeing when we're looking at these demand projections and how much energy that AI is going to consume is we're actually seeing a lot of developers are also, putting in the same project in multiple different places, because again, the time to market is so important that, instead of putting it in one place and you thought maybe you could get like a connection in a short amount of time, you put it in like 6 or 7 places because you don't know where you're going to get your connection because everybody else is putting their data center in 6 or 7 locations. And I do think we're having a lot of kind of double kind of counting there. And as there's kind of few bottlenecks in terms of AI and energy right now. I think they're, the biggest bottleneck is power, and that's what we're talking about. Then there's, the next bottleneck being chips. They're just, these companies that are developing these chips are developing at the most breakneck pace that they possibly can. There's data limitations. There's going to be data limitations. About 10% of the internet has been read in and used for these models, but there's more out there. And then latency issues in terms of like these models are getting so big, it's costing $1 billion to create. When the models are getting so big that you have to have the chips closer and closer together to be able to talk to each other fast enough that sometimes you have to even build the data centers close together, which is why we're seeing a lot in kind of the mid-Atlantic regions, because other data centers there and they're closer to like the the large energy infrastructure. And then there's the second AI for energy, which I think we'll get to in the next bit. But faster exploration, faster design, better assets and controls, which I think we'll get to. And then just because we are at a university to talk a little bit about education, as we're all trying to figure out kind of how we are going to teach our classes in this new paradigm. And I actually. Last night I thought it was kind of funny when Dr. Morrow was coming up here to talk about the Jackson School joining the KBH. The comment was made that for her to talk about whatever she wanted to talk about, which I turned to Michael Weber and I said, well, that's actually a pretty dangerous thing to tell an academic because they may go on. I thought we might get a lecture on subsurface geology, which I would have been here for. But with AI and education, I'm teaching classes trying to figure out what it means, and there's all of the information that can come through this. I teach a class called Too Big to Excel because I wanted to have it a fun name because it's big data, right? Excel can only take 1.8 million rows, but we can do a lot more, now. And I just told my class to, they can use it as long as they, come to class still.
So can I ask you one sort of gut instinct question? Do you find, if you think about the next 10 years, is what AI is going to do for energy, is that more exciting or more interesting than the reverse, which is what energy is going to do for AI? Like, of the two, where do you see the most impact?
Yeah, I mean, I'm hoping the latter is more impactful, right? I'm hoping we get more out of the AI than we really have to put into it. I mean, that's what we would like to.
So it could be, I guess to say, it could be net energy negative. Because we use a lot more to create the AI, but the AI helps us be more efficient. So therefore, it's not really where. But
I mean,
do you think the impact of AI on efficiency has more potential than the excitement around supplying more energy to AI?
I mean, I think the potential exists there. Although as we've seen in other charts and stuff, energy use does just tend to go up. We tend to find more things to use energy with. But I mean, that also can lead to better quality of life and other things. I mean, there are these trade-offs we do make with that.
Every friend I know that has natural gas is really excited about supplying power to AI. So I had to ask the question.
Fair enough.
So Dr. Tuluie, your background is fascinating. You spent a lot of time in automotive, with automotive companies. You were part of a Formula One team. You were the technology officer of the Mercedes Formula One team. I mean, you have seen some really interesting things. And then I bet most of us here don't know a lot about Formula One, but one of the takeaways is it's a place where technology changes very fast, and there's lots of real-time analysis. So in a way, it's a perfect laboratory for what you're doing now at PhysicsX. But maybe just talk about that, your background and how you got so intrigued by AI and everything that comes with it.
Well, you're absolutely right. And as a matter of fact, this is my hometown. I went to graduate school here. And yesterday I was back in the physics department, in the relativity department, giving a talk. And relativity, is numerical physics, right? And you do lots of predictions and you see what happens, which means you have to fly an observatory in the sky or telescopes on the ground. And you have all these theories that you let themselves play out by calculation, and then you have to wait for the result because the satellites aren't there yet, the technology to detect the signals isn't there yet, and you wait 10 years or 20 years, right? And I'm just impatient. And So I went into Formula One, because on Sunday you found out whether you're right or not, on your theories, right? So, so you're absolutely right. It's a super fast development laboratory. It's entirely virtually driven. It's the first instance where the car is entirely virtually designed in a virtual wind tunnel, CFD, tire models, engine models, vehicle dynamics models. And you use that virtual setup to test your ideas, find out what's better, and then you run an optimization loop to continue changing the design, the virtual design. You're not cutting any metal until that car is as quick as you can make it. And then you produce it. And so that whole ethos of very, very fast innovation and virtual production, if you're not using this in industry now, you're behind. If you want to lead in your industry, you got to use that. Now, that transformation has been in industry, has been, asserting itself over the last decade or two. But coming to artificial intelligence, so, AI for energy is one subject, it's a new transformation. It's going to happen again. And these virtual development cycles are going to be driven by artificial intelligence methodologies, like what your students are learning now, is going to be put to use and is starting to be put to use to accelerate the development of our machines in advanced industries and everywhere else. Whether we're talking about materials or aerospace or renewables or automotive.
So the explosion in AI. If we were sitting here together 2 years ago, and I painted the picture of today's world, and here's what NVIDIA has done. Here's what the speculation is around here. Here's what Musk said. Here's what some of the, here's the world of AI. If I'd shown you that 2 years ago, would you have said, yeah, that makes sense because, we're rocking along and that doesn't surprise me. It seems like it has exploded, and so there's something going on here, which is the substance of it has exploded, but also the appreciation of it and maybe the exaggeration of what it might do could have. Where are we on that? Does it surprise you where we are as we think about AI?
One thing that has, the data is there, you look at it, academic publications in artificial intelligence and machine learning have grown at a super exponential rate, from a handful a year to thousands a month. And that tells you something about where the research is going, and the research is going into something that's valuable. Now, there's a lot of hype. You're absolutely right. And, how many more large language models do we need to, help us interpret this or that or be our personal assistant? And I think that market will condense into those sensible things that are actually revenue generating and profit generating. But what we do is when we work these problems, there's a very positive return on the investment of compute, of development, and that return is in the amount of performance a machine generates additionally, or the shortening of the development cycle. So to me, that's not hype. And that's just the beginning of bending this curve, because it's still new technology, it's still immature.
So you, kind of like Matteo in the previous panel, Matteo has a standalone battery company. You now have a standalone AI problem-solving company. What was the attraction for doing it as a standalone entity and incurring the costs and facing all those issues, but having the speed and the freedom? Like, how did you think through this? If Mercedes had said, we'll fund you and we'll create a new division, but you just got to be a part of Mercedes. Like, how do you think about these things, these technological challenges happening in small platforms versus inside a big company?
That's a great question. And let me just abstract away one layer and talk about the companies that have been doing engineering simulation for a long time, the Ansys, the Siemenses, the Dassaults of this world. And they're trying to use, and they're starting to use, and starting to release some software around AI. It's really basic, it's really slow, it's a closed platform, it's not developing at the rate of academia, nor at the rate of startups like ourselves. We are really pushing much faster than that. And so that speed means you're using better models, you're developing new workflows. I'll show you something later if you want to. But and so a legacy company, by virtue of it being legacy, has a slow transition speed. And a startup can have a new concept of what is to be invested in. The technology, there's these deep learning models, Transformers, ChatGPT, that's a handful of years old technology. It doesn't exist. Machine learning existed for decades, but deep learning didn't. And geometric deep learning, which is useful in engineering, certainly didn't.
I'm curious, Dr. Rhodes, here at Texas and in Austin, you and in doing your work, you come across a lot of companies that are doing a lot of things, a lot of different approaches. Like, what are you struck by in terms of the development of AI and how much the pace is quickening? And are you surprised at how fast things seem to be going?
I mean, I think I am surprised at how fast things have gone, because I think, when it hit the consumer level, when the normal person, could ask ChatGPT or Copilot or Llama or Gemini or any of these others, when you could actually talk to it and it talks back to you and you could see the utility there, when you made that jump, I mean, it made it so much more, approachable versus, training a neural network on a bunch of data to, via command line and, just looking at numbers in and numbers out. When it was just, when it became, like you were talking to another person and became more, more valuable, kind of like some of the humanoid robots and things maybe we were looking at in the last bit. But I mean, we talked a little bit like, AI for energy, things that it might be able to do, but in this shorter term, it's kind of more in the energy for AI side, right? Like, how do we provide that much energy to, these companies? I've tried working with some of the companies to try to figure out, can they be flexible? But generally, their work products are so valuable that they don't want to be flexible.
You mean in terms of the reliability of their power or the quantity of the power?
Well, just the technically in training in training a neural network, which is the basic for these, you can pause and then pick up later, and you could reduce your energy use for a certain amount of time, kind of like a demand response product. But it's just so valuable to do so that it doesn't seem like many want to.
The other thing that's going on is all you have to do is say, we got to get this before the Chinese. And then everybody says, go faster, use more power. Is that what do you make of that kind of global competition on which side is going to get there first? How is that really driving the industry like it seems to be at times?
Well, we like that speed, and that competition is internal. It's global. I don't know where it's headed, but we're going as fast as we can.
And who's ahead right now? I know that's a weird question, but I assume.
The West is ahead in our field in terms of applying AI and generative AI to revolutionize the way machines are engineered, and the trajectory is good. We don't see that tooling coming out of China. There's a lot of research, a lot of papers that come out of China, but we don't see that tooling coming out of China. We don't know what the applications are. It's not a market we play in. So far so good. And the really interesting thing is, we're doing this without government support. We're doing this because we have commercial support from the customers we work with. They want this. They want to transform this. It's valuable for them. I'll give you a number. A new platform development of a vehicle in China takes 3 years. In Germany, it's 5 years. Right? How can they get from 5 years to 3 years? It's one of the tools, not the only thing. There's lots of bottlenecks, but it's one of the accelerators to get to 3 years. Right? So even while vehicle development is more expensive in Europe, our ability to affect the rate of development is greater than we think it is perhaps in China at this point, because of the level of maturity and accessibility of software, of people to help with that.
Well, we've got to wrap up. I want to ask the whopper as we wrap up, which is climate change is in and of itself sort of a multivariable, complex equation. Do you think we will see AI applied to that equation? There's a lot of discussion about IPCC models and scenarios, and when you think about modeling something as complicated as the climate over 100 years, that's an amazingly multi-headed problem. Do you think we will see AI applied directly to that?
It has. DeepMind released a model 6 months ago, maybe 9 months ago, called GraphCast. It's a weather prediction model across the globe. It beats anything numerically released by any agency or any private company. It is more accurate, it is faster, it's democratic in the sense that anybody can use it, so adoption is driven very quickly. And okay, it's a weather prediction model. It's not a global warming prediction model. It happens on shorter timescales. It's extremely useful for things like siting, weather prediction, agriculture, and things like that. But yes.
Okay, GraphCast. Well, I wish we could go on. We can't. Dr. Rhodes, Dr. Tuluie, thank you so much. We really appreciate it. It was fantastic.
Thank you.